So today we're doing rational exponents, which means your exponent is going to be a fraction instead of an integer like it was yesterday. So I don't know if the rules we went over last week, this rule is in your notes. If it's not, you need to add it. If you can't read that, it's on page 398 in a box. So what that's saying is this first one is 3 to the power of 1/2. So they wrote it out as the square root of 3. The denominator is your number out here, outside the square root. So this one is 5 1/4. So that's why there's a 4 there. And this one's 2 1/3. So that's why there's a 3 there. And then the numerator sits underneath the square root sign, or the radical, with your whole number. But if it's just a 1 in the numerator, you don't have to write it. And if it's a 2 in the denominator, like in this first one, you don't have to write the 2 out here. You certainly can, but you don't have to because it's assumed to be there. So, the first one we got is 125 to the 1/3 power. And they want you to simplify. So remember, the denominator goes outside the radical. The whole number goes underneath. And the numerator goes underneath the whole number, but if it's 1, it does not matter. So what we have to think of for this one is the cubed root of 125. The cubed root means what number times itself 3 times gets you to 125. Now if you don't know, you're going to kind of have to guess. You're going to be like, okay, 4 times 4 is 16, times 4 is 64. You just pick a few. They're not going to be huge numbers, but I know that 5 times 5 is 25, times 5 is 125. So the cubed root of 125 is 5. But in order to write this out perfectly, I leave the cubed root, and then I say we have 3 5s, so 5 to the 3rd. These cancel out, and when those cancel out, we are left with 5. Okay, so that is the definition of the cubed root of 125. So let's look at like the cubed root of 64. So it would be written like that, and you would put your denominator outside the radical, your base underneath, and then your numerator underneath, which again, if it's 1, it doesn't matter. So 4 times 4 is 16, times 4 is 64, which you could figure that out by using a calculator. So you're going to have the cubed root of 4 cubed, those cancel, and you end up with 4. Okay? So let's look at another one that has an addition sign in it. So here we go. We have 64 1/6 plus 25 to the 1/2. Now what you want to do is you want to get the 6th root of 64 and the square root of 25 and then add them together. So we're going to put the denominator outside our radical, our base underneath, plus our denominator outside our radical and our base underneath. So this is saying what times itself 6 times equals 64. Well, you know, since it's 6 times and 64 is not a huge number, it's going to be a pretty small number. So start with 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay? So you have 6 times 2 to the 6th plus the square root of 25. Square root of 25 is 5. You should know that. 5 squared equals 25. So we are left with, once these cancel, 2 plus these cancel, 5, and you get 7 for an answer. So let's look at some more stuff. Okay, so that rule right there is on page 399. It's a little bit clearer, but this is what I'm saying. This is showing the rule of when you have 8 2/3, the denominator goes outside the radical, the base number goes underneath, and then you square it. And see how it can be in parentheses or not in parentheses. It doesn't really matter. We're going to just put everything in parentheses so everything's the same as this first example. So we have 216 to the 2/3 power of 2/3. So to set that up, your denominator outside the radical, your base underneath, and then we're going to put that all in parentheses, squared. So the first thing we're going to do is what's inside the parentheses, and that's just to help you. The reason we're putting it in parentheses is to help you remember that you're squaring last, because you do whatever is in the parentheses first. So we need the cubed root of 216. So you come up with some numbers. Try 8. So 8 times 8 is 64, and 64 times 8 is 512. So that's too big. So you try your next even number down. 6 times 6 times 6, and you do that on a calculator, and you get 216. So, oops. And actually, there's probably a button on your calculator that shows you exactly what the cubed root is, but I don't have time to look for that. So we get the cubed root of 6 cubed, that's still in parentheses, squared. These cancel each other, and we end with 6 squared, which is 36. Okay? I don't want you just using your calculator and putting in 216, finding the cube root, and then squaring it, and just going from here to here. Because on your test, you're not going to be able to do that and get credit. You need to show the steps you took to get from the question they gave you to a correct answer. So please do your homework like that. Next one is 32 4/5. So the denominator outside the radical, base underneath, put it in parentheses. Your numerator is what your term is raised to. So 32 is already a really small number, and we're going to multiply it 5 times, and it's an even number, so it'll probably just be safe to start with 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we have 5 square root of 2/5 raised to the 4th power. These cancel, which leaves us with 2 to the 4th power, which equals 16. So the approximate number of calories C that an animal needs each day is given by C equals 72 m raised to the 3/4, where m is the animal's mass in kilograms. Find the number of calories that a 16-kilogram dog needs each day. So we're given this formula where m equals mass, and it tells us the mass is of a 16-kilogram dog. So we put C equals 72. We're substituting or evaluating, so 16 goes in parentheses, and that's raised to the 3/4 power. That 3/4 power only goes with the 16 because it's right outside the 16. So then once we find that, we're going to multiply by 72 because you have parentheses. So remember, the denominator outside the radical, 16 underneath, in parentheses, and that whole thing is raised to the 3rd. So again, we have a number times itself 4 times equals 16. So you know it's got to be small. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so we're going to rewrite that. It's 4, and then under the radical sign is 2/4 to the third power. And these cancel each other out. When those cancel, the radical goes away as well. So we get 72 times 2 to the third. 2 to the third is 2 times 2 is 4, is 2 times 8. So we have 72 times 8, and that equals 576 calories. Okay, so we have the cubed root of x to the 9th, y to the 3rd. And we want to rewrite this and take the square root off. So how we do that is we put x to the 9th, y to the 3rd in parentheses, and then this number out here is the denominator, and we put a 1 up top because there's nothing indicating that these two have any other sort of exponent. So now we need to rewrite that. Each one of those terms, this 1/3 here, says that the x is to the 9th is raised to the 1/3, and that the y to the 3rd is raised to the 1/3. So we're going to rewrite that as x to the 9th raised to the 1/3, y to the 3rd raised to the 1/3. Now if you remember the power of a product property, that says that if there's parentheses between your two exponents, you multiply them. So we're going to have x to the 9th times 1/3, and then y to the 3rd times 1/3. That's a 3 right there. So this is saying what's a third of 9? Well, a third of 9 is 9 divided by 3, which is 3. And the y is saying what's a third of 3, and a third of 3 is 1. So this is our answer here. Let's do another one of those. Let's do 4 and x to the 16th, y to the 4th. So we're going to rewrite that as x to the 16th, y to the 4th, all raised to the power of 1/4. Okay, then we're going to take each one of our variables and raise it to the 1/4. And then the power of a product, or power of a power property, is that you multiply those, because I say you multiply when there's parentheses in between the two, because that means to multiply. That's how I remember it. So a fourth of 16 is like saying 16 divided by 4, which is 4. And then 4 times 1/4 is like saying 4 divided by 4, or a fourth of 4, which is 1. Okay, let's look at one that's set up a little bit differently. We have x squared, y to the 1/2, all raised to the 4th. And then we have, beyond that, the cubed root of y cubed. Okay, so this one's a little bit crazier. So this part is already set up like that. So we don't really have to do much with that part of it. We do have to do a little bit with the second part of it. So we're going to leave this as x squared, y to the 1/2, to the power of 4. But if you notice, this 3 and this 3 are the same, which means they can just cancel out, and it leaves us with y. Okay? So, now we have to apply this 4 to x squared and y to 1/2. So we're going to rewrite this like we did up here, right there. And we're going to do x squared times 4. And then we're going to put y 1/2 times 4. And then we're just going to have the y out here hanging out. So 2 times 4 is 8. And then 1/2 of 4 is 2. And then we have this y, which it's being multiplied by. Each one of these is being multiplied by because they're just sitting right next to each other in their variables. And then we simplify the exponents, and when we multiply exponents of like bases, we add them. So we end up with x to the 8th y squared plus 1, because this has a power of 1, which means we get x to the 8th y cubed for an answer. And I was just looking at your homework, and this is number 58, which you don't have to do, but it's a little bit more confusing. So you might run into one of these on an odd problem. So we have the cubed root of x to the 6th y to the 6th over yx squared. So we're going to set this up, and we're going to take x to the 6th y to the 6th. This number is going to, the 3 or the cubed root is going to be your denominator, and your numerator is going to be 1, and that's all over yx squared. And then we can set that up as x to the 6th to the power of 1/3, y to the 6th to the power of 1/3 over yx squared, which then, those parentheses, we use the power product property. Remember the parentheses in between the exponents to remind you to multiply. So we have 6 times 1/3 and y 6 times 1/3 over yx squared. 1/3 of 6 is like 6 divided by 3, and you get 2. 1/3 of 6 again is 2, and we get x squared y. And the reason I switched these two places is so they match up, the bases match up in the numerator and the denominator. Now here's the part where that first part was the same, but they want you to keep simplifying this. And if you ever have a base in the numerator and denominator that have the same exact exponent, so you have an x squared and an x squared, those actually cancel out. Because if you were to look at this, and you were to divide those, which is what the fraction bar is, when you move this up, you get times x to the -2nd, and 2 minus 2 is 0. So let's rewrite that as 2 minus 2, and that equals x to the power of 0, which equals 1. So you don't need those. Now you're looking at y squared over 1, or over y. What they like to have is they like to have one of each base. So we have a y and a y. Well, they want you to combine those, so you only have one base of y. So you have y squared over y, and the exponent with that y is a 1. So we're going to move the 1 to the numerator, so we have y squared times y to the -1, which is y squared minus 1, which just equals y. So the reason we moved this y, or this base, up here is because it would still be positive in the end. And I think we're going to get more into that at some point. We should. I don't know if we will. Might be in a couple lessons or something like that. But just remember, you always move the base that will still, once you combine them by division, will be positive.